Once again, let's do a full recap of what I'm trying to accomplish. So we want to have client 1, browser 1, draw a cube, or draw, or okay, client 1 is going to draw a 3D environment, and we can environment. It keeps trying to autocomplete. Let me just make that. Okay, we're drawing a 3D environment, and then we're going to move the camera using our cursor keys, and then we want to pass that to another client. So we're going to talk to a server, and that's going to send the event to another client, and then draw some avatar presence. Okay, so that's our objective, is to have 3D avatar presence, even if it's just a cube. And to recap, we have a router that is some space, and that's over here. And this is our URL that we'll go to, some unique ID that goes to the space controller. And our space controller is, now we have a unique ID. In the previous video, we have assigned that into the session, and we're pulling it out of the session into something called the assigns, which is just a variable that is available for the templates. And we've added a couple pieces of information. So from the URL, we're pulling out the space ID. So space ID and member ID are now JSON encoded, and we just pass that as vars to the front end, and this is going to render the show template. And the show template is now going to load this file that I created off screen, but I'm going to recreate it again here, called the XRS object. So I put that on the window object, and so when the DOM is loaded, we will pass those vars into its init function, and that is going to be responsible for loading up the broker and the scene and the bus. These are files that we talked about in prior videos, and those will get loaded. So we went through the space controller to the template, the show template, and then finally we're loading up the XRS object. So we're going to call its init function on that. So this is new. In the prior videos we had, well, this is still in app.js, but we have the app.js, and we imported some functions like create the broker, create the scene, and to talk between them we use the bus. And so it was doing all this stuff, but I reorganized the code a bit. So these are now known as services, and so we want to have this sub entry point. So this is the full bundle, but we're just going to really delegate this to the XRS. So if we look at app.js, we are going to import the XRS class, and we're just going to instantiate that and put that on the window object. Then on the show, once again, when the DOM is fully loaded, we'll just grab it off the window object and call its init function. So let's go and implement that piece of code. So we've got XRS, right? And it's going to be a class. So we'll say export class XRS. And we had this concept of that broker and the scene, and this will be a wrapper around those things. So all we have to do is call its init, and that should kick those things off for us. So we'll have some init function, and then we're passing in those vars, right? So the backend is passing in some vars for us, and let's have a type for it. So let's define a type for the config. So type config, and currently we're passing in the member ID, which is a string, and the space ID, which is a string. Now, are these two the only things? I believe so, because if you look at the space controller, we're just passing these two things, And so that's our config. And so what do we want to do inside there? Well, let's just keep a copy of that. So we'll also have our member config, and we'll just assign config to vars of this config. All right, so we have a copy of that. Now, broker, bus, and scene. Broker is for talking with the WebSocket, so it will have an init function to create the channel. Scene will also have an init function, and it will create the canvas and the scene. Maybe I need to change this into something else. What should we call it instead of scene? Because there's a babylon.js scene in this. So this is a game service. Naming is hard. Service engine. Yeah, maybe engine. It's a 3D engine. Service engine. So instead of scene, we'll call this rename this to engine. And maybe that's fine. Okay. So let's make these classes available to this init function. So why don't we just create an object called services, and we'll just define these things here. So I'm going to save some time and just paste this here. I just renamed scene to be service engine, and we'll fix any, let's fix those imports. So I'll go to the top, import these, and this is called engine now, and this will be service engine. So similar to before, we had these as separate functions, and now they're just classes. So now we have these here, and then in init, what we can do is we can just go through each of these services and call their init function. So we'll go through this services, go over, since it's key and value, we'll just go through the values, and for each of them we'll call the init method. And that, for the broker, it will connect to the WebSocket. For the engine, it will create the scene. For the bus, it will create some RxJS subject so we can push messages on there. Let's just review what each of these does. I think broker is going to make some subscriptions, and it will create the channel, and then it will subscribe to some events. I haven't talked about that space channel yet. Let's see, what order should I do this in? Okay, let's talk about it now. So in the recap, the broker part of it, so service broker, which lives inside this right now, what it does is it will create a socket, and then it will create a channel. And we're actually reusing the same socket now. So in app.js, see how it creates this socket, where is that? It will, it creates a live socket here, live socket, new live socket. And we're just going to reuse this live socket. So in the broker, when we create the channel, we're just going to, we used to create our own socket, but now we're just going to reuse live socket. And then we're going to connect to a channel. So this channel is implemented in the back end as space channel. And when you join, it'll call this thing, and you'll get the space ID stored in the socket. But we'll handle in this message I call C to S, which is client to server. So that's incoming messages. And then we'll just turn around and we'll just reflect it back to the other clients. So server to client. We're using broadcast from, so we send it to everybody else but not ourselves. Okay, so that's the backend server side of it. And the type of message we want to receive is something I call a command. So we want to send, we're going to use channel push, and we're going to send something called a command. So if you imagine that before I was just saying, like, you know, person moved, let me comment out a block, more block of line. I was saying the message would be like person moved, and then would have some payload, like maybe the ID of the person and whatever. And this is, and maybe position, rotation, etc. This would lead to a lot of different kind of verbs or messages. So I kind of opted for a more cruddy, generic way, which is to just say client to server, and then the command. And the command, since you're always saying I want to move something in the scene or I want to address something, there's some entity ID. It's the ID of the thing I'm talking about. And then everything else is some properties. So you can set those properties, in which case these are just key value pairs. We'll call them components, but any kind of data. And then this is good for any kind of create or upsert. So if you want to create a new entity, like a new person, you just say the entity ID of the new person, set whatever you want, position, rotation, color, etc. And if you just want to modify an existing entity ID, you still need the entity ID, and then you just the attributes of the parts that you want to modify. Optionally, you can leave this out and you can say delete. So if you want to modify, if you want to delete a component, you can give a list of component names you want to delete. And if you want to delete the entire entity itself, you can pass a time to live of 0, TTL 0, and then we should just delete it from everybody. This command produces a shared JSON object, which will just look like the entity ID. So it might be, you know, ABC and then is components like his position, you know, rotation, etc. So this is a shared object. So these commands end up becoming a serialized JSON object for every client. We have that in common. So we're pushing this command down. Let's define this command shape in the XRS because we're going to need it soon. So underneath type config, let's say export type command, and this is equal to, I'll just paste it here. Like I said, entity ID, string, and optionally one of these, set, delete, or time to live. Okay, so we have the broker, and it can also receive the messages. So when it receives the messages, it's telling XRS to handle the command. So we need to implement a handle command. So in XRS, we can init this, but we also want to receive messages and do something with this. So we'll have a handle command. It will receive a command and do something with this. So we'll say, we'll leave that aside for now. That's what broker does. Bus is different kind of internal messages. So let's just say that we can put, it's the same usage as what we were using it before we were listening to just camera, but now we can specify different types of messages. So head movement, that camera movement is one, but incoming messages, and just think that you can put messages onto here and they don't go anywhere unless somebody subscribes to them. So this is just kind of a passive, we have these things ready, and we'll leave this at that. So bus is just available, it's not doing anything. Engine, formerly scene, creates the camera, it creates the babylon.js scene. So it's doing it all internally here and attaching it to the DOM. And What else should I say? Yes, I added a helper function that can create RxJS style observables from babylon.js's own internal observables. And so here, the camera, when we detect that the matrix is changing, I'm adding a subscription to push a message onto that bus. So here's the camera, and we're saying XRS services bus head movement, which is referring to this guy here, which is just a subject of position and rotation, which is a type of two arrays, position and rotation, that the engine will simply take the camera movement as it's changing and push that data onto the bus. And if nobody's listening, it doesn't go anywhere. So, and finally, we have this store as the final service, which again, it just takes the command. It starts with an empty state object. It takes the command and it will append or merge this command into that shared state object. And it provides some utility functions. All right, so back to the thing that we're trying to do, which is we're trying to listen to camera movement and we want to send it out. So services, I think, should just provide services and not create side effects themselves. I'm leaving side effects or features into another folder called systems. So here, the avatar system will make a subscription. So it's subscribing to the bus, throttled at 50 milliseconds because maybe we don't want to overwhelm the other clients. Then we're going to send a command. So we need to implement this guy. So let's do that next. So we want to implement a send command. Let me just paste this here. So send command takes a command and then an optional send to self, which is a Boolean, and I'll explain why. So we take that command and we go through the broker's service, which is to push that command. So if you look at that broker, we implement a push, which is just to say if the channel is connected, go ahead and push channel to service in that command. So this only pushes it out, but because we're using broadcast from, we don't get our own message. So optionally, if you want to receive your own message, this is set to true. So by default, you do receive your own message, and you will call handle command to process your own message. And what should this thing do? This thing should apply the command. So any data that we get as a command, we're going to apply into that shared store, and we're going to put it on the message bus for incoming commands so that these whoever wants to subscribe to it can do something with that. And so our RxJS, our RxS is nearly complete. The only thing that's missing is the association with the system. So I would like to make those addable and removable at runtime. They're more like features. So I'd like to define an interface. So I'm going to export an interface called an iSystem. And this interface just requires something that has a name and an init method where it takes the RxS object and returns void. And so RxS will keep track of a list of systems. And so we can just say that it's empty to begin with. And then we can just specify a method to add a system. So add a system takes a system, which is a system, and we'll push it into the array. It's an iSystem. And that's pretty much it. So we need to say avatar is one of these things. So we also need to initialize it. So in the beginning, let's just hard code it this for now. We'll say this add system new avatar, or system avatar. We add that. We need to import that. So this is the system avatar. Fix the import. And then we'll go ahead and initialize all systems. So this systems, let's just do for each system, and call system init with this. Okay. And I think that's everything hooked up. Let's see what happens now. Okay, so we have some subscriptions. So once the avatar is initialized, we are subscribing to the head movements that came from the service, this bus, and then we're opting to send the command. So we say, hey, I'm moving my head. So I'm saying entity ID, which I'm just sending the config member ID. Remember, we got this from the backend, member ID, our unique ID. And we're just going to, we're going to fine tune this message later. But for now, we're just going to say, we're just going to set some attributes. So we're going to send the avatar is box and position and rotation, that is the camera. But we're also going to listen to the corresponding commands. So I created this services bus. I created this onset subscription, which is really just a fancy subscription with a matcher. So you can say I match avatar, any command that has avatar. I want to subscribe to that command, and then I want to just draw some stuff. So here I'm just drawing a box, and maybe what I should do is also just look up that mesh if it already exists. So let's say const mesh equal this rxs services engine. Okay, I need to change that back to engine. So here, engine. Oh yeah, I've already said the scene. Okay, so I can just use scene here, sorry. So scene get mesh by name. So we're going to look for the entity ID. So we'll let the mesh be that. So if there's no mesh, then we'll let the mesh be a new box. And then we'll set the position from the position that comes from there. And we'll set the mesh rotation equal to new quaternion. And we'll just set this from like so. Okay. So for every message, we're just find or create the box, and we're also changing its position. Let's test this out. So here we have two browsers connected to the same space ID. If I move this around, I'm producing messages over here, and I'm okay. So I'm backing up, and I believe this box is this guy. So if I move this guy around, okay. So rotation didn't take, but position seems like it is. So I'm moving out, and if I rotate, so the rotation isn't working. But okay, let me get in front. So if I move, okay, so you see the other thing. Okay, so this video is kind of long. I'm going to stop here, and we'll fix that future stuff. But essentially, I have updated the code to have a bunch of services take care of low-level features that are always going to be there, and systems in the future will be the ones to subscribe to commands, produce new commands, throw them over the fence to other clients, and create side effects. So we're leaving all the feature work, the game work, the higher level concepts to systems, and then services provide the base layer of functionality. They provide storage, they provide functions, they provide utility to produce the side effects that we want. Okay.